Let us study chemistry together with CBSE Chemistry tips and tricks.
Calculate the standard cell potential of galvanic cell in which the following reactions take place. You can see two reactions, right? Also, you have to calculate Gibbs free energy change and equilibrium constant. Okay, first we can find standard cell potential. For doing this question, first of all, you must know the reduction potential of cadmium and chromium. See, for chromium, see, chromium means Cr3 plus, right? Cr3 plus to become Cr, the reduction potential is given as minus 0.74. Okay, this you can take from the table, okay, which is given in the textbook. Okay, and in exams they will give this value. Now for cadmium, see, cadmium is what? Cd2 plus, right? Cd2 plus will gain 2 electron to become what? Cd, and reduction potential for that is minus 0.40 volt. Okay, now what is the equation for standard cell potential? E0 cell is equal to E0 cathode minus E0 anode, right? Now who is cathode, who is anode? It's very easy, right? Here who is undergoing oxidation? See, chromium is undergoing oxidation. So chromium is what? Chromium is anode. Okay, this is anode. Clear? And cadmium, you can see Cd2 plus becomes Cd. Oxidation number decreases. So it is reduction and it is cathode. Also, from the reduction potential, you can understand anode and cathode. Understand? The one which has higher reduction potential. It is very clear the reduction potential of Cd2 plus is greater than the reduction potential of Cr3 plus. For Cd2 plus it is minus 0.40. Lesser negative value means higher value, right? Lesser negative means higher value. So Cd2 plus have higher reduction potential, so it acts as cathode. In that way also you can understand. From equation you can understand the one which undergo reduction is cathode. The one which undergo oxidation is anode. From the values also you can understand the identify the cathode and anode. The one which have higher reduction potential is cathode. The one which have lower reduction potential is anode. Okay, fine. Now substitute the values. Minus 0.40 minus 0.74, and you are going to get 0.34. What is the unit of standard cell potential? Volt. So that is our answer. Next we have to find Gibbs free energy change. What is the equation for Gibbs free energy change? It is delta G standard is equal to minus NF E0 cell, right? Now you already know E0 cell value. F value you already know, right? 96500 coulomb. That is something which you are supposed to by heart. Then for finding N value, okay, rewrite the equation. 2Cr plus 3Cd2 plus gives 2Cr3 plus 3Cd. In the question they have already give the balanced equation. For finding N value, either you can choose chromium or you can choose cadmium. So I choose chromium. Okay. So chromium on LHS part, what is the charge? 0, right? No charge at all. But if you check RHS part, you can see 2 chromium ions are there and each chromium have 3 plus charge. So what is the total charge? Plus 6, right? So how many electrons involved? Plus 6 or 6, you can say 6. Correct? Now directly write the equation. Delta G standard is equal to minus 6 into 96500 into what is E0 cell value? 0.34. Easy. Substituting you will get minus 196,860 joule per mole. But usually we represent Gibbs free energy in terms of kilojoule. So you can write like that. Minus 196,860 kilojoule per mole. Okay, hope you understand how to convert joule to kilojoule. Just divide with 1000. Okay, that's it. Just divide the value with 1000. You will get answer in kilojoule. Okay. See, next we are supposed to find equilibrium constant for the first question. Okay, you know there is an equation which connect Gibbs free energy change and equilibrium constant. What is that? See, Gibbs free energy change is equal to minus 2.303 RT log Kc. Direct equation is there, right? See here I wrote delta G value in joule, okay, for substituting here. Okay, so I did the substitution. Delta G value I put here, minus 2.303. R value is 8.314. Right. Now temperature, standard condition, so 298 Kelvin, log Kc. Now we are supposed to make the equation for log Kc, right? So what is that? Log Kc is equal to minus you can cut. So 196860 by 8.314 into 298. This you have to calculate, okay? Into 2.303. I forgot to write that. Sorry. Okay. Now on dividing and multiplication, you will be getting like 34.5014. Clear? Okay, right? So what is Kc? Kc is antilog of what? 34.5. Correct, right? See, by using logbook you can find the answer for this. Answer will be like 3.17 into 10 raised to 34. See, in exams if they don't provide logbook, you can stop your answer on this step. You'll get complete marks. Don't worry about that. Okay. Now we are supposed to repeat the same process for question number 2, right? Okay. So first we have to find the standard cell potential, E0 cell. For that purpose, you must know the reduction potential of Fe3 plus to Fe2 plus. What is the reduction potential? That you have to check your textbook table. Okay, E0 value is 0.77 volt. And for Ag plus, the reduction potential value, again you have to check your textbook table. You can see that value is 0.80 volt. Now you know which one is anode, which one is cathode. The one which have higher reduction potential is what? Cathode. So what is the equation? E0 cell is equal to E0 cathode minus E0 anode. Understand, right? This is cathode because it have higher reduction potential. This is anode because it have lesser reduction potential. Substitute the values like 0.80 minus 0.77. You will be getting like 0.3 volt. So we got the reduction potential of the second question, right? Standard reduction potential. Okay, or standard cell potential. Clear, right? Sorry, it is not 0.3. 0.03 volt. Okay, 0.03 volt. That is the right answer. E0 cell value is 0.03 volt. Okay. Now what we have to find? Gibbs free energy change, right? What is equation? Delta G standard is equal to minus NF E0 cell. Correct, right? You already know E0 cell value. You know F value, right? What is that? 96500 coulomb, right? Now we have to find N value. For that purpose, either take Fe or Ag. So I choose Fe. So Fe, what is the charge on LHS? It is plus 2. Now what about RHS? Plus 3. So what is the change of electron? 1. So N value is what? 1. Easy, right? Substitute minus 1 into 96500 into E0 cell. E0 cell is what? 0.03 volt. On multiplying, you will get like minus 2895 joule per mole. Okay. Now, usually delta G represent in kilojoule. So, minus 2.895 kilojoule per mole. See how to convert joule to kilojoule? Divide it with 1000. Easy, right? Now, what we have to find? Equilibrium constant. What is the equation which connect Gibbs free energy and equilibrium constant? Standard Gibbs free energy change is equal to minus 2.303 RT log Kc, right? And what is Kc? Kc is delta G standard by minus 2.303 RT. So it's for log Kc, okay? Log Kc. Log Kc is this one. Now, what is delta G value? Minus 2895. Take joule value, okay? Don't take kilojoule value. Okay, because we are dealing with SI unit. By minus 2.303 into R is what? 8.314. As it is standard temperature is 298. On dividing, you will get like 0.5074. Okay. Now, this is log Kc, right? Log Kc. Now, what is Kc? Take anti-log of this. Okay. So, anti-log of 0.5074. Okay, right? So, you can use logbook 3.22. Okay, you are getting the final answer. Hope all of you understand.